Good morning to all of you. This is Dr. Umesh Kumar Singh. Today we are going to discuss about the pressure measurement. In the previous session we have discussed about the gauge pressure, absolute pressure, vacuum pressure. Also we have discussed about the Pascal's law, that is how to measure the pressure. What is the formula for the pressure? That is the P equal to, you see, that is the P equal to rho into G into H. P is the pressure at that point, rho is the density of the fluid, G is the acceleration due to gravity, H is called the pressure head. H is called the pressure head. This is the pressure. Density rho, G is the acceleration due to gravity. Atmospheric pressure, a standard value at sea level at 15 degrees centigrade is 101.325 kilonewton per meter square. You can convert in the other unit also, 10.13 in unit of Newton per centimeter square and 1.033 in unit of kgf per centimeter square. Already conversion formula is given in the previous session. 1 kgf is equal to 9.81 Newton. So as per the previous session, we are going to compute the atmospheric pressure head in case of the mercury, atmospheric pressure head in case of the water. You know the formula P equal to rho GH. In that, what you have to find out? This is the pressure head you have to find out. Pressure head, that is the value of H. Value of H can be written as P upon rho G. Now the first case is the mercury. First case is the mercury, second case is the water. Now we are going for the first case. We are going for the first case here. Let me see. This is the first one. First, this is the second case. So for the first case, that is mercury is there. For the first case, P equal to, you know, rho GH, or better to write H in terms of H, as you have to find the H. H is equal to P upon rho G. So this P, how much pressure is there? You have to compute the atmospheric pressure head. That is the pressure head when it is atmospheric. When the pressure head, how we can define the atmospheric pressure head? When the pressure is atmospheric pressure, then corresponding to that the head is called atmospheric pressure head. That means if you see here, P equal to rho GH, in that what is? P is the pressure and head, H is the pressure head corresponding to this pressure. If this pressure is atmospheric pressure, then this head is called the atmospheric pressure head. That means in case of the atmospheric pressure head, pressure is atmospheric pressure, and you know the value of the atmospheric pressure, that is 101.325 kilonewton per meter square. So you know the value of this P, that is 101.325 101.325 multiplied by 10 to power 3 for the kilo, then you will get the Newton per meter cube, Newton per meter square. This is the pressure, this is how much Newton per meter square. Okay, divided by the density. In the case of first, mercury is there. What is the density for the mercury? If the density of the mercury is given, or you have to realize the standard value of the density for the mercury, that is 13600, density of the mercury. G 9.81. Whatever the value you are getting here, that you will get the head, pressure head, atmospheric pressure head when the mercury is the fluid. Similarly, in case of the second case, H equal to P upon rho G. P value already you know, 101.325 into 10 to power 3 divided by the density of the, The second case, density is water, fluid is water, so density of water you have to take, that is 1000, 9.81. You will get here the value of the atmospheric pressure head. So after getting the atmospheric pressure head, you have to compare which value is more, which value is less. That is the main point of given this question. Giving this question, main point is that you have to compare the atmospheric pressure head as fluid is changing. If the fluid is changing but on the fluid atmospheric pressure is there, then pressure head will be how much. So you can compute the pressure head, atmospheric pressure head in this way. So this is about the how to compute the atmospheric pressure head. Now we are moving to the manometers. Let's see different type of manometer. First we define the manometer, then we will go to the manometer types. This is the again one problem is given. Okay, let's discuss first this problem, then we will see. What is this problem? The pressure intensity at a point in a fluid is given. Pressure intensity, that is the pressure is given 3.924 Newton per centimeter square. Find the corresponding height of the fluid when the fluid is water, when the fluid is oil, and that oil is having the specific gravity of 0.9. So you have to compute the corresponding height of fluid, that is the pressure head. Corresponding height of fluid, that is the pressure head you have to compute. So pressure head, that is P upon rho G. For the first case, water is there. P value is given 3.924 Newton per centimeter square. We have to convert this into the SI unit, Newton per meter square. So how to convert that one? 3.924 into 10 to power 4. 1 meter, you can convert centimeter, 100 centimeter, or 1 centimeter, that is 1 upon 100 meter, or 10 to power minus 2. So 10 to power minus 2, that is here 10 to power minus 4, it will go 10 to power 4. So this is the pressure P. In the first case, density is, that is for the water, 1000 G 9.81. You will get the head. In the second case, oil is there. So for the oil, P is the same, pressure will be the same, then liquid is changed there. Liquid is changed, liquid becomes the oil. So then this pressure value is 3.924 into 10 to power 4 divided by rho into G. Rho is the density of the oil. How much density of the oil? A specific gravity is given 0.9. Density is not given. A specific gravity is given. Then its density will be what? Density will be what? 0.9, a specific gravity multiplied by the density of the water, that is the 1000, that is 900 kg per meter cube. So 900 is the density of this oil as per the specific gravity 0.9. So 900 here density you have to write for the oil into G. You will get here the fluid height, that is the pressure head. In this way you can compute this question. So let's move to the next manometer. Manometer. How can you define the manometer? Manometer is a device that is used for measuring the pressure. In the previous we are measuring the pressure using the some equation. Now in the manometer, how we will get the pressure? Manometer is the device for measuring the pressure at a point in fluid by balancing the column of the fluid by the same fluid or by the another column of the fluid. So manometer simply is a device that gives the pressure by which we can able to get the pressure. So different types of manometer are there. Broadly, simple manometer and differential manometer. So what is simple manometer and what is this differential manometer? Let's see here. Simple manometer, that is it consists of a glass tube. It consists of a glass tube. Simple manometer consists of a glass tube having one of its end connected to a point where the pressure is to be measured. Where the pressure is to be measured, and the another end remains open to atmosphere. It is having two ends. See, glass tube is there. It is having two ends. One is connected to the point where the pressure has to be measured. This is, you can see, this is the pipe. This is the pipe, and manometer is connected in this pipe. This is the manometer which is connected in this pipe. So this manometer is having two ends. You can see, this is the one end, this is the second end. So one end is connected to the pipe where the pressure has to be measured. At point A, pressure has to be measured, so it is connected to the pipe, one end, and the other end, you can see here, another end is open to atmosphere. So that is the picture view of the simple manometer. So simple manometer category having the piezometer, U-tube manometer, and single column manometer. So this is also called the piezometer, having a simple manometer. Let's see these different types of manometer. What is the main characteristics here? One end is connected to the tube or pipe where the pressure has to be measured, and the another end is subjected to atmospheric pressure. Piezometer, like the simple manometer, simplest form of the manometer, using for the measuring of the gauge pressure. So here one end is connected. One end is connected to the, you can see here, one end is connected to the manometer. One end of the manometer is connected to the point where the pressure has to be measured, and the another end is open to atmosphere. So that is the piezometer. So next one is this is the simplest form of the manometer. U-tube manometer, you can see the picture, U-tube manometer. It is having the shape of U-tube. It is having the shape of U. So it consists of the glass tube bent in U shape. Consists of glass tube bent in U shape. One end of this tube is connected to a point where the pressure has to be measured, and the other end remains open to atmosphere. You can see here, this is the U shape, having the glass tube having the U shape. That is called the U-tube manometer. One end is connected to the pipe where the pressure has to be measured. Pressure has to be measured at point A here. So it is connected to the pipe where the pressure has to be measured, and the other end is subjected to atmosphere. It is open to atmosphere. But because this is the same case for the previous pitot tube also, but that is having the single column like that one. It is having the U shape. That is the U-tube manometer. So generally it consists of, you can see the two liquids are there here. You can see if one is the blue liquid, that is the flowing in the pipe. One is the another gray color liquid which is in this tube. So this tube is having the both liquids, the liquid which is in the pipe blue, and the liquid another liquid in the tube. So generally this U-tube manometer have the another liquid as mercury. So there is the two fluid is there in this U-tube manometer. One, the fluid which is having the fluid in the pipe, and another fluid, that is the mercury. However, it is not necessary always. Single column manometer, that is it is the modified form of the U-tube manometer, in which reservoir having a large cross sectional area about 100 times as compared to the area of the tube is connected to the one of the limbs of the manometer. You can see this is the single column manometer, that is in between the manometer. If you see in the previous slide here, in between A reservoir is connected here. A reservoir is connected here, that is having the area about 100 times of this tube area. So that is called the single column manometer. Now we are moving to the next one, differential manometer. This is the important one. Previous also the important ones are there. So what is the difference between these two, you will see. The differential manometer, that is it's the device that is used for measuring the difference of pressure. In the previous case, it is used to, that in the previous case, manometers are, simple manometer are used to measure the pressure, but this differential manometer are used to measure the difference of pressure between 2 points in a pipe or in two different pipes. In a single pipe, 2 points may be there or two different pipes may be there. We can see, for the example, one pipe is A, another pipe is B. So the two different pipes are there. At point A, this is the one pipe, this is the second pipe. In first pipe, point A is there where the pressure has to be measured, and in second pipe, point B where the pressure has to be measured. So now we are interested in measure the pressure difference in between A and B, that is in the different pipes are there. So for this you have to connect the manometer, that is the differential manometer we have to connect. Even a single pipe is there, if single pipe is there, you want to know the point A and point B is there, you want to know the difference between the pressure at point A and B, then in that case we have to connect the differential manometer at point A and B. If single point is there, in that case you have to connect the simple manometer. That is the difference between the main difference between the simple manometer and differential manometer. Simple manometer is used to know the pressure at a single point, while the differential manometer is used to know the difference between the pressure at 2 points. These 2 points may lie in a single pipe or may in the two different pipes. In that case, differential manometer is used. So this is about the manometer. Thank you for this session. Thank you.